The AI revolution is reshaping tech like never before. From Apple Intelligence to Microsoft Recall and Meta AI, buzzwords like on-device AI are everywhere. Tech giants are racing to run complex machine learning models right on your phone or laptop, no cloud servers needed. At the heart of this shift, a tiny but mighty chip called the NPU, or Neural Processing Unit. But is it a game changer or just another hyped-up trend like NFTs or the metaverse? Why are Apple, Microsoft, and AMD betting big on it? Join Boardroom Secrets as we dive into the electrifying world of NPUs, the tech powering the AI future. Let's unravel this mystery. What's an NPU anyway? Picture a cutting-edge chip like Apple's M3 Max. It's a system-on-chip SoC, a high-tech orchestra of components. The CPU for general computing, the GPU for graphics, specialized units for displays and ports, and here's the star of the show, the NPU, or what Apple calls its neural engine. This tiny chip is built from the ground up to handle AI tasks, like recognizing your face or blurring your video call background. But here's the kicker. Despite all the hype, the NPU takes up surprisingly little space. On the M3 Max, components like display processors dwarf it, sometimes by 5 times. Yet its presence is no accident. Every square millimeter of a chip is prime real estate, so dedicating space to an NPU, even on compact chips like the iPhone's A17 Pro, is a calculated move. On smaller devices, where space and power are tight, the NPU's role grows even bigger. Take Lisa, a graphic designer using a new MacBook. Her NPU quietly powers real-time photo edits, cropping, filtering, even suggesting layouts without draining her battery. Why? Because NPUs are designed for efficiency, not just raw power. Boardroom Secrets Insight: AMD's CEO revealed Microsoft pushed them to double down on NPUs, signaling a seismic shift in chip design. So, what makes NPUs so special, and why do they matter? Why computers need specialized AI chips? Computers are math machines at their core. Every task, playing music, rendering a game, typing a document, boils down to numbers and calculations. In the early days, CPUs handled everything. These versatile workhorses are precise and powerful, tackling complex math with pinpoint accuracy. But not every task needs that level of finesse. Enter specialized chips. Think about graphics. A 4K display has 8 million pixels, and refreshing at 60 frames per second demands 500 million calculations a second. CPUs couldn't keep up. That's where GPUs came in, packing thousands of tiny cores to churn through simple, repetitive math at lightning speed. Over time, chips for video encoding, camera processing, and more joined the party, each tailored for specific tasks. Now, AI is the new frontier. NPUs are custom-built for neural networks, the backbone of AI. They handle tasks like voice recognition, photo analysis, or predictive text with insane efficiency. On an iPhone, Apple says 200 neural networks run simultaneously, powering everything from Siri to Face ID. These networks rely on repetitive math, multiply, add, repeat billions of times. NPUs are designed to nail this, sipping power while doing it. How neural networks work without the hype. Neural networks sound futuristic, almost magical, but strip away the marketing fluff and they're just math. Let's break it down with a simple example. Imagine a neural network, call it Netty, tasked with spotting a diagonal line in a tiny 2x2 pixel image. Each pixel is either white, 1, or black, 0. Netty's made of neurons. Think of them as memory cells holding numbers. These neurons, arranged in layers, are linked by weights, or numbers that tweak calculations. Here's how it works. Feed the 4 pixels into Netty's input layer. Each pixel's value gets multiplied by a weight, summed up, and passed to the next layer. By the output layer, if a neuron hits 1, Netty's saying, yup, there's a diagonal. No 1, no diagonal. It's just multiply, add, repeat. Nothing mystical, just fast math. Real-world neural networks are way bigger. Billions of neurons, thousands of layers, trillions of parameters. Training them to recognize faces or generate art takes massive server farms guzzling power. But once trained, NPUs let devices like your phone apply these models locally, fast and frugal. That's why NPUs are popping up in phones, smartwatches, even AR glasses, anywhere AI needs to run on a tight budget. NPUs versus GPUs, the showdown. Here's where it gets spicy. NPUs sound cool, but GPUs, those graphics beasts, have been running AI for years. High-end GPUs like NVIDIA's 4090 pack tensor cores, specialized AI hardware with over 500 cores. Even integrated GPUs like Intel's Lunar Lake chips now boast AI muscle that sometimes outpaces NPUs. So why bother with NPUs? It's all about efficiency. GPUs are power-hungry speed demons, perfect for heavy AI tasks like rendering AI-generated art or crunching complex models. But for lightweight, always-on tasks, NPUs shine. Take Qualcomm's Snapdragon X Elite. Its NPU sips under 5 watts at full tilt, letting it run AI in the background without killing your battery. Think heart rate monitoring, motion detection, or fall alerts on a smartwatch, tasks that need stability, not raw speed. Picture Alex, a marathon runner with a smartwatch. His NPU tracks his steps, heart rate, and even flags an irregular heartbeat all day long without needing a charge. A GPU doing that? Battery's dead by lunch. Boardroom secrets takeaway. NPUs aren't here to replace GPUs. They're the sidekick, handling the small, constant AI jobs that keep devices smart and efficient. The future, game changer or gimmick? So are NPUs the next big thing or just tech hype? Right now they're a mixed bag. Features like Microsoft's Recall, AI that snapshots your screen and indexes it for instant searches, are NPU gold. It runs quietly in the background, saving power while making your PC a memory vault. But privacy concerns linger. Constant screen recording? Some users feel like Big Brother's watching. Other NPU tricks like Windows Studio effects, blurring video call backgrounds, filtering noise, are neat but not jaw-dropping. Real-time translation during meetings or auto-generating captions? Useful but not revolutionary. The problem? NPUs excel at low-key tasks, but the flashiest AI demos, like generating images or running chatbots, still lean on GPUs. For NPUs to steal the spotlight, developers need killer apps that scream NPU or bust. Imagine this, an NPU-powered assistant that listens to your meetings, summarizes key points, and drafts emails, all offline, all day, without a battery hit. Or smart glasses that recognize objects in real time, guiding the visually impaired. Boardroom Secrets prediction: NPUs will shine in wearables and IoT, where power efficiency is king. But on desktops, where GPUs rule, NPUs need to prove their worth beyond marketing buzz. The big picture NPUs are no gimmick. They're a strategic bet on an AI-driven future. Apple, Microsoft, and AMD aren't pouring billions into them for nothing. Since 2017, NPUs have spread from phones to laptops, driven by the need for on-device AI that's fast, private, and power efficient. But their full potential? Still untapped. If developers unlock truly innovative uses, NPUs could redefine how we interact with tech. If not, they risk being a footnote like 3D TVs. The AI race is on, and NPUs are a key player. Will they spark a revolution or fade into the background? Stay tuned with Boardroom Secrets as we track the tech shaping tomorrow. What do you think? Game changer or overhyped? Let's hear it.